All right. We are supposed to solve this equation analytically. What kind of equation is this? What kind of equation are we looking at? It's not quadratic. What'd you say? Absolute value, yes. This is an absolute value equation. How many answers are we going to get from an absolute value equation? 2. Why 2? What does absolute value mean? What's it telling us about? Positive or negative, distance away from 0. We've got 4 steps when we solve an absolute value equation. What is our first step when we are solving an absolute value equation? Isolate. We want to isolate the absolute value. We're going to use order of operations to help us do that in the correct order. So I've got PEMDAS. We're going to go from the bottom up. Anytime we are isolating, we're solving. So what operations would I have to start off by undoing if I'm going backwards through the order of operations as I'm isolating? Adding and subtracting. When we are isolating our absolute value, we are not allowed to touch any of the stuff on the inside. Is there anything that I could get rid of using adding or subtracting if I can't touch the inside? That 1. How do I get rid of it? -1 on both sides. Thank you, sir. All right. 2 times the absolute value of x minus 6 equals what? 9. Because I did 10 minus 1. Is my absolute value isolated yet? No. I'm still not allowed to touch the stuff on the inside, so what do I still need to get rid of? The 2. How is the 2 connected to that absolute value? It's being multiplied, so how are we going to get rid of it? Divide both sides by 2. That does not get rid of those absolute value bars on either side. All it did was get rid of the 2. What's 9 cut in half? 4.5. All right, so that finished up my isolate step. We still have 3 more steps to go. After we isolate, what do? What does absolute value mean again? What does absolute value mean? How far it is from 0. So if I tell you I'm 4.5 units from 0, where could I be? Yep, I could be at positive 4.5 or negative 4.5. That's our second step, is to split this up into 2 cases, the positive and the negative case. So I'm going to let case 1 be my positive case. It does not matter which is which. I'm going to let case 2 be the negative case. When you split it into 2 cases, the part inside the absolute value, that x minus 6, stays exactly the same in both cases. For the positive case, I take what's inside the absolute value and I set it equal to a positive 4.5. So what would it be equal to on my negative case? Negative 4.5. That right there finishes off my second step. So I've isolated it. I have 2 cases. What do I need to do to both of those cases now? We need to solve them. What do I do over here to get the x all by itself? We're going to add 6 to both sides. So add 6, add 6. What is x? Sorry, not x. What is 4.5 plus 6? 10.5. What do I do over here to solve for x? Add 6 again. So I'm going to add 6 to both sides. What is negative 4.5 plus 6? 1.5. right, we're almost done. We got one more step. What is my last step? Starts with a C. Check. Yes. We have to check each one of those answers now by substituting it in to our original absolute value. So 2 times the absolute value of, let's check 10.5 first. 10.5 minus 6 plus 1, and that should give me a 10. Gentlemen, if you're not talking about math, shut it. Yes, sir. They're right up here, honey. What is 10.5 minus 6? 4.5. So that's inside the absolute value. What is the absolute value of 4.5? How far away is that from 0? 4.5. So I have 2 times 4.5 plus 1. What is 2 times 4.5? No. 4.5 and then another 4.5. 9. So I have 9 plus 1. What is 9 plus 1? 10. What did I have on the other side all along? 10. Does this check out? Yes? No? Yes. The two sides are equal. So 10.5 is one possible answer for x. So do we just leave it at that and call it done? Have to check the other one. So I have 2 times the absolute value of 1.5 minus 6 plus 1, and that's supposed to equal 10. What is 1.5 minus 6? Negative 4.5. What is the absolute value of negative 4.5? How far is that from 0? 4.5. So I have 2 times 4.5 plus 1. 2 times 4.5 is 9. So I have 9 plus 1, which is equal to 10. What did I have on the other side? 10. Does this work? Yes. All right. So we got 2 valid answers for this absolute value. Why do we have to check again? What happens if we did it right, but then when we check it, it doesn't work? It does not mean that we messed up a step. It means the answer is not valid. The answer is extraneous. It does not mean that you made a mistake, and I still need to see your work for it, but we would not circle it at the end as an answer. We would put an X across it and say it is extraneous. All right. We are going to be in your books today, pages 95 and 96. So we're going to start off on page 95. Page 95, and the first thing we're going to do is talk about point slope form. Point slope form. All right. Last week we spent most of our time when we were talking about linear equations, so on Friday, talking about slope-intercept form. What does slope-intercept form look like? Y equals mx plus b. And what does slope-intercept form tell us about our line? It tells us the y-intercept, yes. This piece right here is specifically the y-intercept. Which part of my equation is the y-intercept? I have y equals mx plus b. Which piece of that is my y-intercept? B. B is my y-intercept. What else does slope-intercept form tell me about? The slope. Tells me about my slope. Which piece of this equation is the slope? M. Not the mx, just the m. All right. So that's slope-intercept form. Today we're going to talk about point-slope form. And we're going to learn how to go from point-slope form into slope-intercept form. Point-slope form is y minus y1 equals m times x minus x1. What's the same about these two? They both have slope. They're both going to tell me the slope. And what letter represents the slope? M. So here's my slope. And then it says point. This is just some point, any point. The y-intercept is a very specific point. With point-slope form, I need any point on the line. The point in point-slope form comes from y1 and x1. So our point is x1, y1. The y minus part, that's just part of my equation. So I'm going to see y minus and then the y part of the ordered pair. Inside those parentheses, same thing. I'm going to see x minus and then the x part of the ordered pair. Do you guys remember how when we were talking about transformations, h was the opposite? It was always the opposite sign of what I saw? That's true about both the x and the y in point-slope form. If I see x minus 5, 5 is the x part of my ordered pair. If I see y minus 2, 2 is the y part of my ordered pair. What do you think it would mean if I saw y plus 3? If I saw y plus 3, what's the y part of the ordered pair? If I see y plus 3, what would y1 be? What's the y part of the ordered pair? It is not 1. It's not 3. But 3 is the closest guess I've heard. It is not. Nope. Nope. Negative 3. I said that first. Yeah. We should see a y minus right here. If you see a plus, then that came from doing y minus negative 3. Because what happens when we subtract a negative? We are moving further to the left, but what happens just with my signs if I have y minus negative? It's going to turn into a plus. When you subtract a negative, it turns into a plus.
I thought it only works with multiplication.
Yep, technically we're multiplying a negative 1 to this negative 3. So you're absolutely correct. When you subtract a negative, you're multiplying it by negative 1. Yep. All right, I want to practice this. So we're going to write an equation in point-slope form, and then we're going to convert it into slope-intercept form. We're going to do the converting part in the margin. We're going to look at example 5. What information did they give us to work with in example 5? What do we have to work with in example 5? 3 and negative 5. So here's my point. What else do I have? I have a slope of 11. All right, so right here is my point-slope form. Y minus y1 equals m, and then inside parentheses, x minus x1. Things that will stay the same. The y and the minus will stay the same. And then I'm going to substitute a value in here. Equals, we're going to substitute in our value for m. And then I have x minus, and then we're going to substitute again. The x and y parts of my ordered pairs go on these lines, and my slope goes right here. Thank you, sir. What is the slope? It is m, but what's the value we're substituting in? 11. So right here, I'm going to substitute in 11 for my slope. Where do I put the 3? Where should I put the 3? Is that the x part or the y part of the ordered pair? That's the x part. So where should I put that? The first line or the second line? This is x. Where do I put x in at? On the second one. x1 goes back here, so I have x minus 3. Where do I put the negative 5 then? On that first line. Here's y1. What can I do right here to simplify this? Turn it into a positive. We should never have subtracting a negative in a final answer. So this is going to be y plus 5 equals 11 times x minus 3. That is my point slope form. That is my point slope form. I can see the x part of the ordered pair. Ibrahim, put it away. The x part of my ordered pair is right here, after the minus sign. The x part of the ordered pair is a positive 3. It comes after my minus sign. Here's my slope. Where do you see the y part of the ordered pair? But it's not 5. We said the y part of the ordered pair was what? Negative 5. If you see a plus, it's the opposite of that. So it's negative 5. You okay?
Sorry.
Okay. You need to be in the margin for this point, or for this part. We're going to go from point slope form into slope intercept form. To take this into slope intercept form, the first thing I need to do is with that 11. What do you think I want to do with the 11? What can I do with the 11? It is my slope. What can I do with it? Yep, I'm going to use the distributive property. So I'm going to have 11x minus 33. What's the last thing I would need to do to get the y all alone? Subtract 5 from both sides. So I have y equals 11x minus what? Yep. Close. No. When I'm subtracting, I'm at negative 33, and when I'm subtracting, I move further to the left. Negative 38, so minus 38. This is slope intercept form. Point slope form. Point slope form, I still have that slope of 11, but it uses any point that's on that line. Slope-intercept form very specifically has the slope and the y-intercept, so where it touches the y-axis. You guys ready to try another one? All right, we're going to go into point slope form again. Yes? I am very sorry to hear that, sir. All right. Example number 6. What did they give us to work with on example 6? They gave me the slope formula. Yeah. I have how many points?
Wait.
2 points.
2, yes. Sorry, I thought you were talking about each individual number.
I have 2 points here. Did they tell me the slope? Did they tell me the slope? No. I'm going to have to find it using these 2 points. Slope is rise over run. Rise is the change in my y values divided by the change in my x values. We're going to have to pick one of these points and we're going to call it point 1. We're going to call the other point point 2. It does not matter which is which. You make that decision. Which one do you guys want to call point 1? First one sounds good. So this will be point 1. And so we're going to call this one over here point 2. Shh. Guys, I'm not so sure how well choosing your own seats is working. We've gone from doing a reasonably good job listening and paying attention during class to I have to spend more time getting your attention back on the problem, off of your friends and off of your phones. We're never going to learn and pass Algebra 2 with that kind of behavior. You guys get one more day. If we can't get it together by tomorrow, I'm assigning seats. When you're looking at an ordered pair, which part always comes first, the x or the y? X. So in point 1, this would be x1 and y1. In point 2, the 7 is x or y? X. So this is x2 and y2. Yes, sir?
Never mind.
Okay. So we need to find our slope. I'm going to subtract these two. Two numbers on top of each other in the fraction when I'm finding slope have to come from the same ordered pair. Yes, sir?
Since it's subtracting, if one of them was already like a negative, it wouldn't matter.
It won't necessarily matter. It means you would subtract a negative, though, so that would turn into addition if that happens. Yes. What are we going to put in for y1? Or sorry, for y2, because that's my first number. 13. What am I putting in for x2? x2. Where's point 2? I need x2. Remember, if they're on top of each other like this, they have to come from the same ordered pair. Only these numbers are allowed to be in the front. Y on top, because that's my rise. X on bottom, because that's my run. So 13 over 7. Then we subtract the x and the y from the next point. 1 and 1. What's 13 minus 1? 12. What's 7 minus 1? Can I reduce 12 over 6? What does that reduce to? 2. So what did we just find? What is 2? What did we just do all that work to determine? The slope. So now we know our slope is 2. We need to take that information, we're going to turn the page, and we're going to finish this problem. Rest of this is on the top of page 96. All right. We know that the slope is 2. What were the 2 points that we had to work with? What were the 2 points that we used to find our slope? 1, 1, and 7, 13. Yep, we are on the next page. So this is point 1. This one here is point 2. Here's my point slope form. What do I keep from this form? What am I not substituting into? Which pieces will stay the same? From my form, from what I have a red box around, what will stay the same? What'd you say? Y will stay the same. What else? The X will stay the same. Will anything else stay the same? Because I still see 2 things that are going to stay. I already brought the equal sign down. Slope will be the same in my form, but I'm not going to write M. I want to know from what's in the red box, what's going to stay the same? The negative, the minus sign will stay. That is part of my form. You have to bring that down and recopy that. What'd you say? Do you need your own paper to do this on? Do you need to borrow some from me? You only need to correct the ones that you missed. Just write down the problem number. How many points do we have to work with? We have 2 different points. Put the phones away, please. I could write 2 different correct answers here. What's the slope for both of these? The slope is 2, so that's going to stay the same between these. If I used point 1, what would I fill in these 2 spots? 1 and 1. What about if I used point 2? Which one would I put here? 13. Why 13 first? It's the Y part and a 7 right here. Yep, that's where slope throws people off. And anytime we have a slope form, you got to watch that because you're right. X, Y is how we see our ordered pairs. That's alphabetical order. Slope has Y on top and X on bottom. Point slope form has Y first and then X. Are these describing the same line? Are these describing the same line? Yes, let's prove it. Y minus 1 equals 2 times X minus 1. Shh, please stop. I'm going to take this 2 and distribute it. So I'd have 2X minus 2. How do I get Y all by itself now? Add 1 to both sides. What's negative 2 plus 1? Negative 1. All right, so there it is in slope-intercept form. Let's try the same thing with the other equation that we wrote. Y minus 13 equals 2 times X minus 7. What's the first thing I should do here? Multiply. I'm going to distribute that 2 to both pieces. So I get 2x minus 14. What do I do to get the y by itself now? Add 13 to both sides. What's negative 14 plus 13? Negative 1. This is in slope-intercept form now. What do you notice about those two slope-intercept forms? What is true about the slope-intercept form no matter which point slope I started with? They are the same. So do these two equations over here describe the same line? Yes, when I put them in slope-intercept form, they are identical. They're describing the same exact line. It does not matter which point you use when they ask you to write it in point slope form. If they give you 2 points, you can pick whichever one you want. We've got one last example to look at together. Example number 7. We are down at the bottom of page 96. The Tower of Pisa began tilting during its construction in 1178, and it continued to move until a restoration effort reduced the lean and stabilized the structure. The Tower of Pisa leaned 5.4 meters in 1993. Compared to a lean of just 1.4 meters in 1350. We're going to write an equation in point slope form that represents the lean, y, in meters of the Tower of Pisa x years after its construction. Which variable are we using for y? Or sorry, what are we measuring with y? Meters. What's being measured in meters about this tower? How tall it is?
Wait, no.
What's being measured in meters? The lean. So it's supposed to be straight up and down, but it has lean, so they're measuring this distance right here. So the lean is our y variable. So what is our x variable? Years. Just years? What's it say? Years after its construction in 1178. We're going to round things to the nearest hundredth. How far is the nearest hundredth? How many decimal places? How many numbers after the point? 2. 2 decimal places. The tower was leaning 1.4 meters in 1350, which was how many years after it was constructed? How would I find that? How long it had been standing in 1350? Subtract. What am I going to subtract?
1,350 minus 1,100.
Yep, 1,350 minus 1178. This was the year it was built. So how long had it been standing in 1350? What is 1350 minus 1178?
1150. No, 1182.
You're close. You got a couple too many numbers in there.
I mean,
What'd you say?
282.
100.
Oh, 100, my bad. 100.
Yep. 172. Pop those in your calculator and subtract. It's 172.
Wait, how'd you get the 7? Because isn't that...
Right. 1350 minus 1178. I'm going to have to do some borrowing. So I have to borrow from here. 10 minus 8 gives me 2. 4 minus 7, I can't do that, so I have to borrow again. 14 minus 7 gives me 7. So 172.
Yeah, right, the bottom, 75.
Yep. In 1993, how long had this tower been standing? How would I find that? Subtract again. So 1993 minus 1178. How long had it been standing? 815 years. Same kind of thing that we did to find the other one. 1993 minus 1178. I'm going to need to borrow. 13 minus 8 is 5. I don't need to borrow anywhere else, just for that first piece. All right. So now we want to find our slope. Why do they have 5.4 minus 1.4? Those are which values? The y's. Remember, it's y in the top. Change in y for my rise. What is 5.4 minus 1.4? 4. Down in the denominator, where did the 815 and the 172 come from? Possibly. But where did those numbers come from?
Years.
Years. Is years x or y? X. Down in the denominator is our change in x, because this is our run. Guys, you've got to get this straight about slope. Slope, the numerator is my rise. Rise goes up and down. That's your y values. I need the change or the difference in my y values divided by my run, the change or the difference in my x values. That has to go in my denominator. Rise on top of run. So 815 minus 172. So 3, borrow, 643. Grab your calculators. 4 divided by 643. Tell me what this is as a decimal. You said 0 point what? 0.006. So 0.006 as a decimal. Is that a positive or a negative decimal? Positive. So does that mean the lean is increasing or decreasing? Increasing. Positive values means that it is an increase. It is increasing at a rate of 0.006 meters per year. That doesn't seem like very much, right? 0.006, that's like 6 millimeters a year. That's not very fast, but this building has been standing for over 800 years. So 6 millimeters every year, it eventually will lean too far and fall over. That's why they had to stabilize it.
Wait, isn't a millimeter 100 of an inch?
Millimeters and inches are two different units of measurement.
I know, but like,
Millimeters go with centimeters, go with meters. A millimeter is 1/1000th of a meter.
oh, okay, I was making
Yeah. Inches to meters, we have to convert. All right, I want to write this in point slope form. We're going to write two different correct answers here. What did we find our slope to be again? What was the slope? 0.006. From this form right here, no matter which point I'm using, what's going to stay the same? Y. Y, X. What'd you say? The negative signs, the minus signs are going to stay the same. And the equal sign. I'm going to have two correct answers that are going to have all these pieces the same. What else will these two answers have that's the same? They're going to have the same slope. 0.006. What will one of these look like? Give me one of them. What am I substituting in here and here? 1.4. Where would I put the 1.4? Is 1.4 the x or the y part of the ordered pair? Y. So I put it next to the y. All right. So what do I put here? 172. The x part has to go next to x. The y part has to go next to y. 5.4 next to the y. 815. There we go. Either one of those would be absolutely correct. How could you prove to yourself or to me that these are the same? How would you check? What could you do? We can't solve it. Solve means I find a final answer, a final value. I have two variables here. What could I do to check? What did we do here? We put them both into slope-intercept form. And if they represent the same line, what should be true about those? They should be the same. So what could we do here if I asked you to prove to me that these were the same? You could distribute, combine your like terms. You could turn both of them into slope-intercept form to prove to me that they are the same. If all I do is ask you for point-slope form, either one of these would get full credit. You don't have to give me both. Just give me one of them. Sound good? All right. That finishes us up for today. You guys have homework due tomorrow. We still have 10 minutes of just in-class time. And then we have our D lunch time that you guys can work on this homework or any other homeworks.